Okay, so I'm going to run through these slides really quick, just background. I would say just the takeaway from the description of our school is that it's a public institution with a huge range in abilities and students who don't have a lot of time outside of class to put into their homework because, not because they're lazy, but just because they have other obligations like family and work. And so they're not lazy, they just don't have the time. The course, I think, was pretty standard. It's just a discrete math class, as I think anyone would know it. I think, again, the most important part of this slide, or the most important piece of information to get out of this is that it does serve as our transitions class to upper level mathematics, and it does serve as our intro to proofs. And so that was kind of what I think both of us were keeping in the back of our minds as we were going through this, is that yes, though the course is required for all computer science majors and it does have to serve their needs, it also, in the end, is a math class and it does have to serve the needs of the math majors. And so notice just the last bullet point is that we had both previously taught this course in just regular traditional lecture style. So why change now? This is sort of my path to how I ended up deciding to teach this class in an IBL style. The main impetus, I think, what got it going was I had a semester where I was concurrently teaching abstract algebra and discrete math, and I was horrified at how underprepared the abstract algebra students were. Probably I'm going to see some nodding heads because you've seen this happen before. In particular, they certainly couldn't prove things very well or even attempt to prove things, which supposedly they had passed a course saying that they could do that. And even just conceptually, just basic content, they couldn't read set builder notation. So again, I was pretty frustrated by that. And so unfortunately, I took it out on my discrete math students at the time. I was like, oh, well, these students are going to know how to write proofs. And so I graded them really, really hard. And needless to say, that didn't go over well. I got pretty poor evaluations that semester. So I just kind of realized, oh, the chemistry's off. I'm not accomplishing what I want to accomplish, and they're resenting what I'm asking. I also attended last summer a conference with my provost on course redesign, and that was not just for math, that was across all the disciplines. And it was actually really big for me to realize that our provost is on our side. He is actually interested in seeing course redesign. Now, sort of the asterisk there is with results. He's not so much interested in it for ideological reasons. He's interested in it because he wants to improve graduation rates. So for him, increased learning should improve graduation rates. But I felt that I had support, and that really helped. And then there were a couple of other things that contributed to this, I guess, epiphany of mine. So just by coincidence, on my way to Math Fest last summer, I sat next to this gentleman on the plane. I assume, does everyone know who that is? Yes, Ed Berger, yeah, yep. So he was my seatmate, and we struck up a conversation on inquiry-based learning and discrete math, and who else would be better to sit next to on the plane to have that conversation. And then lastly, once I got to Math Fest, I was lucky enough to meet this gentleman, who is also one of the gods in teaching discrete math with inquiry-based learning. So I assume all of you know that that's Ron Taylor, right? Okay. This slide just kind of represents what is common to both Roger's and my version of the course. So I think what's interesting is that we did use exactly the same course notes, which are the notes that are circulating right now. We both had classes that met twice a week for 100 minutes each, and we spent about half the time on student presentations, half the time on group work. We both, in the spirit of IBL, tried to offer limited coaching and guidance during the presentations and would give brief commentary after a presentation if needed. And then we both had a cumulative final. And I want to just quickly show you an excerpt. I know that the notes are going around, but I just want to kind of highlight sort of the idea behind our notes. So this is sort of what a typical introduction would look like. Now, I know this is really too much text to just sit and read through right now. But so we would start off with a definition. I would assume that this definition is going to seem, pretty familiar. We would maybe have some just exposition kind of explaining it. We would have an example, and maybe contained within that example would be a non-example. Then maybe some more exposition. It is often helpful to think of it this way. Right? Let's see. And then Maybe a little bit later we would have an exercise, just asking them to use that definition to just kind of get their hands a little bit dirty. And then maybe again later after a few more definitions. So this would have come after the definition of image of a set under a function. And so we would have them compute some of these objects. And then we finally get to what we would call the problems. Now, unfortunately, half the problem is missing here. There's supposed to be two parts to this problem. So the first problem is just computing f of s union t and f of s union f of t. And the second part of the problem would be to prove that those two were equal. And when we said prove that those two were equal, we did mean by showing both set containments in a fairly rigorous way. That is what we meant. So. And again, if you want to take a closer look at those notes, those are going around. So this is the last part that I'm going to talk about, and these are just the specifics of the way I ran my course. So I'm not saying I think this is the best way to do it. This is the way everyone should do it. I did it twice, and this is what I decided to do for me. And you'll see in a minute that Roger did his very differently, though we used exactly the same course notes. So for me, I had no lecture ever, not even mini lectures, nothing, none. The students would try the problems together in their groups and on their own outside of class before they would present. So when my students came to the board, I did actually expect that they would have moderately or mostly correct solutions because they had had time to work on them. The presentations were graded on a 20-point scale, 10 points for correctness, 5 points for clarity, and 5 points for their response to the audience questions. And the last thing on that bullet point is kind of a big one. The audience members were not allowed to take notes. So I definitely have sort of philosophical reasons why I stuck with that. Maybe I'll wait until the end if there's time for questions to kind of go into that, because I want to make sure Roger has enough time to talk about his version of the course. The participation grade was broken down into 3 components. Their in-class presentations, their feedback on other students' presentations, and I kind of kept a running log of that throughout the duration of others' presentations, and how well they worked in their groups. This next bullet point for the handwritten problems, this I stole straight from Ron Taylor. This was his idea, and he didn't mind if I took, if I borrowed whatever I wanted, so I took this. They had to turn in 50 problems by the end of the semester, with a maximum of 6 per week. And each problem was graded out of 10 points with no specific rubric. And among those 6, they could turn in as many rewrites as they wanted. So if they turned in a rewrite, it did count as one of their 6 for the week, but of course it didn't count as a new problem toward their 50. Okay. So that's sort of one of the themes that I've heard kind of throughout this conference is the idea of putting the decision-making in the students' hands. And this was one aspect that where I really felt I accomplished that, because they had, full choice over how many problems they were going to turn in, which ones they were going to turn in, and when. And versus how many they were going to rewrite. So this was an aspect of the course that I did really enjoy. So I'm going to advance this to Roger's turn.
So Rachel put in a ton of work preparing these notes about a year ago, I think. And then I was also teaching discrete, and we were discussing her new experience, and she realized how interested I was and offered to share the notes with me. So I jumped at that, and this past semester both of us taught discrete. It was my first time formally doing this IBL modified Moore method. I didn't know what I was doing. I knew I would enjoy it. I knew I would love to see the students active and the engagement and so on. So it was really learning by just jumping in. I tried at first not to give any lectures, and I found certain points would occur in the course where the confusion, rather than sort of resolving itself as one would hope, just seemed to spread and get worse. And so I felt like I sometimes had to stop things, give some clarifying context maybe, and fix some misconceptions and so on. So I ended up doing some little lecturing like that. And from that I decided, well, when a new topic is introduced, it might also be helpful to kind of go through discussion, maybe lecture, at least to throw out some of the terminology that was going to be involved, to kind of build a context for these different ideas. The students had very little, well, it was their first proof-based course, so they really hadn't been through an experience building on definitions and so on. I was very concerned to get all the students presenting, and it worked out pretty well. I'm not sure how that happened, but with mild encouragement from me, it was pretty well balanced in the presentations. I was concerned about the pacing of the course. I didn't want to let the sharpest students lead the pace, because that would have left, I'm sure it would have left many students behind. So I tried to keep it balanced between group work and presentations, which meant I kind of had to act as MC and moderator to an extent and push things along, always wishing the students would take over more autonomy in doing that, but haven't really learned to do that yet. Another thing I found helpful was I occasionally required outside of class presentations. This began when I put the classic square root of 2 problem on a quiz, and they knew it was going to be on the quiz, and it's in the notes, and we discussed it because I know it's not always easy to catch the spirit of that proof just by a read-through of the notes. And still most of them missed it. And so I told them if they could still get credit for that missed problem, but they had to come to me and present it in person. And that was a great learning experience for me. Many of them were very, very challenged to learn that complete proof and be able to discuss it and really feel that they had mastered it. It was a greater challenge for many of them than I ever really had suspected.
What was the theorem?
Oh, the square root of 2 is not rational. The famous one. So Rachel has course evaluations from the time she did it. We don't yet have them from this last semester. But here, just briefly, we put up some of the results, and you can see 4 of our 11 questions that we thought were most pertinent are shown there. Lots of A's, B's and C's, hardly any D's and F's from the student evaluation. So that was rather pleasing to see. Written comments, there were just a few. This was from your small class, right? The Moore method was a unique approach that at first I was hesitant about, but it ended up working out really well, and other math professors should maybe try it. So that was a pretty good comment. This one's different. Moore method is a very flawed method of teaching abstract ideas. Not everyone learns the same way. Give different examples of the same material. And the third one is the most interesting. I don't really like the students teaching each other technique very much, but I have noticed that it works pretty well. So that's great to get that response from a student. I think my time is up. Is that right? Okay, there was just a couple more that you could probably guess at what our observations of such a course would be. So thank you very much.
If you said it, I missed it. How many presentations did they have to do?
Yeah, that's a really good question. So I taught the class twice, one time with about 15 students, and one time with 33. So what I kind of did was I sent, in the first time I taught it, I set kind of this benchmark of 3 presentations per student for the whole semester, and then beyond that would be gravy. But then when I had the larger class, I kind of had to reduce it to 2 because, for obvious reasons. So yeah, that's kind of where I set it. But I didn't know in the beginning how many presentations I was going to be able to require. So I kind of had to feel
I'm
it
guessing
out.
then that you've answered my second question. I was wondering about your 20-point scale, because I also give them a grade when they go to the board. And you said 5 out of the 20 points was for audience, how they responded to the audience questions. I'm just picturing in my class there might be no questions or only 1 question, but that didn't happen to you since each presentation was a pretty big deal?
It happened once in a while, and in those cases, they just got those 5 points for free. So that was just that was my solution to that. But it actually didn't happen that often, especially in the larger class. I actually had, it was a quiet day when I only had 5 responses. So, yeah. Yeah, so I have a couple reasons for that. One is that in my class, students were allowed to turn in problems after they'd been presented for 75% credit. So that was one reason. And then the other reason is that in the times when I did say leave someone's presentation up on the board when they transitioned to group work, and so they kind of had it to look at, inevitably I received almost carbon copies of that problem later on, and I just found it was so hard to break them of wanting to copy a template that I find that it's easier if I just don't allow them to have access to that template, and that way they just focus on understanding, and because they have the group work immediately after the presentation, that at that point they can kind of clarify things in their head and make notes. And so I think I probably have to stop, right? Yeah, but I'll be happy to talk to anyone after, both of us will. So.